If you follow our channel or astronomy developments regularly, you probably already know that the new James Webb Space Telescope is about to completely revolutionize our view of the universe. In September of last year, NASA released another image of the new super telescope that caused quite a stir. The image shows the icy planet Neptune, and it's the best we've seen of this fascinating planet in 30 years. In fact, Neptune is one of the least explored and thus most mysterious planets in the solar system. Before we move on to the blue ice giant, we'd like to invite you to subscribe to our channel if you haven't already done so anyway, and activate the notification bell so that you're guaranteed to not miss any of our future videos. Also, give us a like at the end of the video if you enjoyed the latest findings about Neptune. We'll start now with a few facts about the blue planet at the end of the solar system. Neptune facts. Neptune is the 8th known planet in the solar system as seen from the Sun, and since Pluto was stripped of its planetary status in 2006, also the last. Measured by diameter, Neptune is the 4th largest, the 3rd most massive, and the densest planet in the solar system. It has about 17 times the mass of Earth and is slightly more massive than its nearly identical twin brother, Uranus. Neptune is composed mainly of gases, liquids, and ice. Officially, it's an ice giant. For one orbit around the Sun, Neptune needs, at a distance of 2.8 billion miles, a whopping 164.8 Earth years. Neptune was the first planet to be discovered by mathematical calculations alone. Galileo Galilei had already noticed the blue phenomenon in the 17th century, but he mistook Neptune for a star. Not until 1846 did the British mathematician and astronomer John Couch Adams uncover via mathematical calculation that there must be another planet behind Uranus, discovered in 1781. Couch's calculations were confirmed at about the same time by the French astronomer Urbain Le Verrier. The planet was first seen by a German astronomer named Johann Gottfried Galle on September 23, 1846. Looking up at the night sky from the Berlin Observatory, he identified Neptune as the 8th planet in the solar system. The trademark of Neptune is its blue color. This is due to the peculiar vibrational pattern of the molecular structure in gaseous methane, which makes up the bulk of Neptune's structure. The bluish color also earned the planet the name of the god of the sea. Neptune is one of the least studied planets to date. Observations of the planet's atmosphere over the past few decades have revealed sometimes dramatic changes in the structure of the ice giant. This has led to great concern among scientists. With so little data known about Neptune, researchers didn't know what to do with these observations. James Webb's image of Neptune. The first exciting images of Neptune were provided by the Voyager spacecraft in 1989. Launched in 1977, the probe reached the planet after a 12-year flight. Neptune, however, was not Voyager's destination. The Voyager dual probe had been designed to fly through the entire solar system and then enter interstellar space. This image was to remain the best mankind had of Neptune for more than 30 years. The first Hubble Space Telescope also provided images of the ice giant, but the quality was rather mediocre. Scientists were all the more excited for the launch of the new James Webb Telescope. In September 2022, we saw Neptune in a completely new way. Not only did Webb capture the clearest view of this distant planet's rings in more than 30 years, its cameras also show the ice giant in an entirely new light. The image was taken with the NIRCam near-infrared camera, which images objects in the near-infrared range of 0.6 to 5 microns. In this way, Neptune does not appear blue, but very dark. The dark areas are most likely methane gas, which strongly absorbs red and infrared light. The bright stripes and spots, on the other hand, are clouds of methane ice. Due to the reflection of sunlight, they appear almost white. Thanks to this technique, Neptune's fine ring system became clearly visible for the first time. The rings have long been known to scientists, but previous technologies were barely able to visualize or image the rings, which are presumably made of ice crystals. The thin, bright line orbiting the planet's equator suggest atmospheric circulations. In plain language, these are violent winds and storms raging on Neptune's surface. A previously known vortex at the South Pole is clearly visible in the James Webb image. Also, a first is the depiction of the continuous band of clouds that envelops the planet at higher latitudes. Light filtering methods allow scientists on Earth to determine the exact composition of gases and other structures from a distance. Studying the rings alone, first observed by Voyager 2 in 1989, will provide exciting new insights into the ice giant at the end of the solar system. For astronomers, this is a milestone in the study of Neptune and the long-awaited consolation for NASA's lack of funding for its own Neptune probe for the time being. The Great Dark Spot. The processes on Neptune's surface are among the last great mysteries of the star system. In 1989, Voyager 2 discovered the so-called Great Dark Spot during its flyby in Neptune's southern hemisphere. This is a gigantic whirlwind, similar to the Great Red Spot of Jupiter. In 1994, a team of researchers using the Hubble Space Telescope set out to study the Great Dark Spot in more detail. To the researchers' astonishment, however, the high-pressure area the size of Eurasia had suddenly disappeared. Instead, the scientists found a new dark spot in the northern hemisphere. The fact that this had also disappeared after only a few years showed that the enormous storms that dominate Neptune's surface are far more short-lived than those of Jupiter. On its surface, the storm known as the Great Red Spot has been raging for centuries and in exactly the same place. Neptune's storms may be shorter-lived than those of its big brother Jupiter, but as far as wind speeds are concerned, Neptune is the undisputed king in the system. Its storms reach incredible speeds of 1,305 miles per hour. In comparison, the most violent tropical cyclones reach only about 186 miles per hour, so you really don't want to encounter a Neptune storm. Unexplainable processes on Neptune's surface. In 2020, scientists were thrown into turmoil. A team of researchers from the University of California at Berkeley used the Hubble telescope to observe a storm on the surface that was wider than the Earth's Atlantic Ocean. The storm originated in the northern hemisphere of the planet. Since the discovery in 2018, Berkeley experts have been looking annually at what's happening. In 2019, the storm began to drift southward, moving toward Neptune's equator, where storms usually dissipate. But to scientists' surprise, Hubble discovered in August 2020 that the vortex had changed direction again and was heading back north. Although Hubble has tracked similar dark spots for nearly 30 years, this atmospheric behavior was something entirely new. Researchers do not yet know what these movements mean or whether the events are simply rare or worrisome anomalies. The largest storm Hubble has ever observed on Neptune was 4,600 miles in diameter. Researchers have been observing the behavior of the storm since 1993, and they noticed that the storm seemed to disappear several times, perhaps actually dissipating, only to reappear not far from where it disappeared. Scientists would love to know more about these events. A theory says that the storms disappear only superficially, but continue to rage in the deeper layers of Neptune. From time to time, the events could then become visible again on the surface. We do not yet know what exactly is happening in Neptune's deep layers. NASA would have to send a probe to the blue planet. Similar to Cassini, this could be brought down over the planet at the end of its operating time. During the flight through the layers of Neptune, researchers could finally obtain the data they have been longing for. This is still a pie-in-the-sky idea, but it's certain that Neptune will also get its own probe at some point. Perhaps NASA will combine a mission to Neptune with the search for the mysterious planet X, whose orbit is said to be behind Neptune. Since Pluto is no longer a planet, Neptune is the eighth and last of the major planets in the system. However, orbital calculations of some other objects in the solar system have provided multiple hints that there must be another large planet behind Neptune. Planet 9, or Planet X, could be orbiting the Sun in a highly eccentric orbit, so far out that it has not yet become visible because of poor lighting conditions. If Planet X orbits so far out, its orbital period around the Sun could be up to 1,000 years. Theoretically, this planet would only become visible to modern telescopes every few hundred years. Neptune's largest moon, Triton. We'll finish by taking another look at James Webb's brand new image. Surely, when you saw the photo, you immediately wondered what that beautiful blue-green light in the background of Neptune was. Well, even though this apparition looks like a brightly shining star, the mysterious green sparkle is simply a moon. This image shows 7 of the 14 Neptune moons known so far, and the one shining so brightly is Triton. Triton is the largest of Neptune's moons and about the size of Earth's moon. Because this moon orbits its planet in an extremely elliptical orbit, researchers hypothesize that Triton may have once been a Kuiper Belt object captured by Neptune's gravity. The moon appears greenish in this image due to the special color filtering of the image. As an icy moon, Triton also perfectly reflects the sparse sunlight. On Triton, similar to Jupiter's moon Europa and Saturn's moon Enceladus, ice volcanism has been observed. There is probably even a liquid ocean beneath the moon's ice crust. So, a Neptune probe would truly have a lot to explore in this part of the solar system. Until that time comes, we remain curious about what new observations the James Webb Telescope will surprise us with. It's certain that researchers will now regularly take a look at Neptune with the new telescope. You have never seen Neptune like this before. The James Webb Space Telescope outdid itself again in September 2022 by capturing a stunning image of Neptune and its rings. This image provides the clearest view of the rings of the distant planet that we have ever had. Indeed, the fine dust rings are not visible to the naked eye. They shimmered ever so slightly in an image taken by NASA's Voyager 2 spacecraft in 1989. But the quality of the image was barely enough to draw more accurate conclusions about the ring's composition and origin. The Webb telescope image clearly witnesses even the fainter dust rings of Neptune. This image was made possible by the near-infrared camera, or NIRCam for short, which can image objects in the near-infrared range from 0.6 to 5 microns. Due to light filtering, Neptune does not appear blue to the Webb telescope, but shines brilliantly. The image continues to show 7 of Neptune's 14 known moons. Triton, Neptune's large and unusual moon, dominates this image as a very bright point of light. Triton reflects an average of 70% of the sunlight that hits it, far outshining Neptune. This image is fascinating not only because of its unusual angle of view and its impressive composition. Scientists have gained completely new insights into the dynamics and composition of the planet and its moons. Almost at the edge of our solar system. Up to Neptune, the official major planets of the system are Mercury, Venus, the Earth, Mars, Jupiter, Saturn, and finally Uranus and Neptune. Until 2006, we had another planet, Pluto. But since the discovery of more Pluto-like objects in the fringes of the solar system, these mini-planets have been demoted to so-called trans-Neptunian objects. The size jump from Neptune to Pluto is indeed huge. Pluto is not even half the size of its neighbor. Because of its remoteness, Neptune is the least studied planet in the entire solar system. For a long time, researchers also thought that Neptune was not particularly exciting because hardly any life was suspected in this darkness, and the ice planet was considered barren and desolate. But this was a mistake. According to the newest realizations, one of the coldest planets in the system could support an ocean of hot water, and in this, even life forms would be conceivable. Neptune is an ice giant, about 4 times the size of Earth. It has a radius of about 15,300 miles and a volume of 15 trillion cubic miles, giving it a bottom-line volume 58 times larger than Earth. Neptune's main constituents are water, methane, and ammonia. Like the other ice and gas giants in our system, Neptune has no solid surface. Its atmosphere extends deep into the planet to the mantle, which consists of methane and ammonia ice and a rocky core. Yet scientists believe the ice giant may have an internal warm to even hot ocean. More alive than thought. Neptune's secret is that it is by no means as dull as researchers long thought. Scientists became aware of Neptune when they discovered that it has an active climate and some of the most violent and powerful storms in the solar system. The climatic phenomena on Neptune are much more like an oversized rocky planet than a gas planet. Measurements have revealed that Neptune's solid core may be larger and more complex than long thought. In fact, intense geological processes inside the planet can explain the weather phenomena. But not only that, model calculations have shown that Neptune could harbor a warm ocean beneath its ice. Sunlight travels a full 4 hours to reach Neptune's surface. Neptune's average atmospheric temperature is minus 182 degrees Celsius, making it one of the coldest objects in the solar system. Between the years 2003 to 2018, the planet experienced significant cooling, and at the same time, temperatures at the South Pole rose in 2018. Researchers noticed an interesting change in the chemical composition of Neptune's atmosphere in this context. These very changes provided evidence of internal heating produced by gravitational compression, or gravitational interaction between Neptune and its moon Triton. This naturally raises the question of whether life could exist on Neptune. For a long time, researchers thought that this was not possible, but this view is slowly changing. Since we have found life in the most impossible places on Earth, we have to open our minds to the possibility that life may exist in places in the solar system that we have previously overlooked. For a long time, we searched on Mars, and even Venus will soon be examined more closely for traces of microbes in the atmosphere. But Neptune was not on anyone's radar during this search. Some very brave scientists even suggested that some of the strange spots on Neptune might be caused by swarms of bacteria under the thick ice. This theory currently finds few supporters, but who knows? We may be in for a surprise. Neptune's troubled past. Another explanation for the enormous internal energy inside Neptune could have been a collision with a cosmic object. Since Neptune is the only planet that radiates nearly 3 times as much energy as it receives from the Sun, some as yet unknown mechanism must be at work. Another clue is the unusual 28-degree tilt of the axis. The axis tilt is similar to Earth's and explains why Neptune experiences seasons. Unlike on Earth, a season on Neptune lasts not just a few months, but a full 40 years. Because of Neptune's long distance from the Sun, the clocks run a little differently here. Not only are the seasons a bit longer than on Earth, but also a Neptune year is a bit longer, at 165 Earth years. However, since Neptune rotates quite quickly around its own axis, a day on the planet lasts just 16 hours. The planet's rapid rotation generates some of the strongest winds in the solar system. Neptune is the windiest planet in the system, and winds quickly assume speeds of up to 1,900 kilometers per hour. This makes Neptune's storms even stronger than those on Jupiter. Similar to Jupiter, Neptune also has a large storm that forms a prominent surface. The Earth-sized cyclone was first discovered by the Voyager 2 spacecraft in 1989. In 1994, the storm had disappeared from a new image taken by the Hubble telescope. Instead, a small, new spot had appeared in the northern hemisphere. In contrast to the 300-year-old cyclone on Jupiter, the violent storms on Neptune exist only 2 to 6 years. Since Neptune has certain similarities with Jupiter and has a kind of mixture of a rocky planet and a gas planet in its interior, researchers came up with an interesting idea. Neptune seems somehow out of place on its position at the outer edge of the solar system. From the evolutionary history of the planets, Neptune may have once formed between Mars and Jupiter. It's quite possible that some planets in our solar system have exchanged places in the course of time. Thus, Neptune could have been pushed to the edge of the system by the tremendous gravitational forces of Jupiter. Another crazy theory says that Neptune is so different from all other planets because it did not originally come from our solar system at all, but was captured as a vagabond planet by our Sun at some point. If this theory is correct, Neptune would be an alien world which quasi-cheated itself into our solar system. Why is Neptune so blue? Neptune's atmosphere is 80% hydrogen and 19% helium, with the rest being other gases, including some methane. In fact, it is this small amount of methane that colors the planet deep blue. Methane molecules absorb solar radiation in the short-wave region and reflect the color blue. Uranus has a very similar distribution of gases, but unlike Neptune, its color is pale blue. Researchers from Oxford University tried to unravel this mystery. In their thesis, they suggested that this difference in color could be due to the density of the methane nebula. Both planets have several layers within their atmospheres formed from fine aerosols. The bottom layer is a mixture of hydrogen disulfide ice. The second layer is probably exactly what turns both planets more or less blue. Since Neptune's atmosphere is much more active than Uranus's, its second aerosol layer is thinner. Because of the lower density, more light is reflected, and this provides the intense blue color. The third atmospheric layer consists of large particles of methane ice. The retrograde moon, Triton. Thanks to James Webb's new image, scientists will unlock the secrets of Neptune's best-known moon, Triton. Triton is a very active moon. Its surface is covered in methane and nitrogen ice. Methane flakes appear, and Triton has very active volcanoes. Researchers have not been able to explain how the heat inside and the unusual volcanism came about. It was thought that the seventh largest moon in the solar system is heated by Neptune's gravity. The volcanoes emit a mixture of cold dust and gas into the thin atmosphere. It is possible that these ejections are involved in the formation of Neptune's fine rings of dust and gas. A very similar process has been observed in the vicinity of Saturn. There, the icy moon Enceladus feeds one of the gas giant's outer rings with tiny ice particles. Triton is special among the moons of the solar system because it orbits retrograde around its planet. This suggests that it may once have been an independent object captured by Neptune. The unusual retrograde orbit and its intense reflection have led to speculation that this moon was originally a Kuiper Belt object, gravitationally bound by Neptune. Researchers now hope the new image and much more information will finally clarify where Neptune really came from and when and how Triton became bound to it.
Neptune. With an intrinsic diameter of about 30,000 miles, Neptune ranks fourth in the list of the largest planets of our solar system. With its impressive dimensions, the celestial body dwarfs our blue home planet by about fourfold. In contrast to the Earth, however, Neptune's composition is not made up of solid substances, but of volatile chemical compounds. Specifically, the upper atmospheric layers consist of hydrogen, helium, methane, and ethane. Together with Uranus, Neptune is among the ice giants within our planetary system. In view of this designation, one could assume that the corresponding planets would have a permanently icy structure. However, this is not the case. In truth, the corresponding compounds are in the form of supercritical fluids. This means that they are in a special state of aggregation, which combines the properties of gases and liquids. Although the orbit of the bluish shimmering ice giant was already suspected at the beginning of the 17th century, it took until 1846 before the existence of our galactic neighbor was proven beyond doubt by mathematical calculations and observations. By the way, the celestial body owes its name to the old Romans. Within the time-honored Roman mythology, Neptune was regarded as the lord over the seas. In view of the planet's bluish coloring, which actually resembles water, this choice of name seems extremely appropriate. However, as you may have guessed, Neptune's surface coloration is not due to a galactic water supply, but to large amounts of methane. The distance between the ice giant and the Sun naturally brings some direct accompanying effects. It's almost 3 billion miles from our host star. To completely orbit the Sun once, Neptune needs a period of almost 165 years. At the same time, the days on the ice giant are significantly shorter than on our home planet. Due to its volatile nature, the gigantic celestial body needs just 16 hours to rotate once around its own axis. Since there is a huge distance between Neptune and the Sun, the intensity of solar radiation on the planet is also relatively weak. Consequently, the ice giant is characterized by frosty cold temperatures. Thus, the maximum temperature in the upper layers of the planet amounts to only -330 degrees Fahrenheit. Although the planet is composed, as mentioned, mainly of volatile chemical compounds, the assumption is obvious that the ice giant has a solid core of the approximate size of our Earth. Temperatures around the planet's core would be as high as 12,600 degrees Fahrenheit. Incidentally, Neptune does not move through space alone. As we know today, the planet is accompanied by at least 14 natural satellites. With an equatorial diameter of over 1,500 miles, Triton is the largest of all known Neptune satellites. Neptune in all its glory. If we take a look at the overall view of the planet, we are authentically made aware of the natural beauty inherent in our secluded galactic neighbor. In addition to the planet's characteristic blue coloration, the large cloud formations immediately catch our eye. In contrast to their terrestrial counterparts, however, these natural structures have a completely different chemical composition. For example, experts believe that Neptune's clouds consist mainly of methane gas. The ring system of the ice giant. During its journey into the realms of Neptune, Voyager 2 succeeded in capturing not only the planet, but also its fine ring system on camera. In contrast to hundreds of thousands of orbits around Saturn, the rings of the ice giant are much more manageable. The individual galactic orbits are sometimes conspicuously dark. This is due to the fact that the rings of Neptune, just like the rings of Jupiter and Uranus, contain a very high proportion of microscopic dust particles. Experts suspect that the dust bodies were kicked up by meteorites hitting the planet's moon. Neptune clouds in detail. This fascinating close-up view of Neptune's clouds shows that the natural structures in the planet's uppermost layers form vertical reliefs. Those parts of the clouds that face the sun are much brighter than the parts of the cloud cover that are not directly exposed to sunlight. The clouds we see in this image are 30 to 95 miles wide and extend over a length of many thousands of miles. In detail, the image was taken 2 hours before Voyager 2's closest approach. On August 25, 1989, the spacecraft passed the celestial body at a distance of just 3,000 miles. The Great Dark Spot. The Neptune mission was also the first to discover a structure on the planet that was henceforth referred to as the Great Dark Spot. At first, terrestrial scientists assumed that this ominous Great Dark Spot was a gigantic cloud. However, later investigations suggested that the structure was actually a hole in the cloud cover. At its core, it was a cyclone system with the combined size of Asia and Europe. In all likelihood, the Great Dark Spot moved counterclockwise and took 18.3 hours to completely circle the ice giant. When the Hubble Space Telescope wanted to take another look at the gigantic whirlwind in 1994, the surprise among the experts was great. The Great Dark Spot had disappeared. To this day, researchers do not know what processes led the cyclone system to disappear from the scene. One thesis says that the storm fell victim to the heat of the planet's core. The idea that the Great Dark Spot simply dissolved or was veiled by other parts of the atmosphere is also discussed in the ranks of scientists. Small Dark Spot and Scooter. The Great Dark Spot was not the only cyclone that raged on the ice giant. In fact, Scooter, which we recognize in the image as a central white cloud, had already been detected 2 months before Voyager 2 arrived in the realms of Neptune. Scooter was much faster than the larger dark spot. The smaller galactic storm needs just 16 hours to make its way once around the ice giant. The small dark spot was no less intense. The small dark spot, which we can see at the bottom of the image, appeared during the arrival of Voyager 2 as a conspicuously dark structure. As the spacecraft approached Neptune, a bright core crystallized. Proteus. On its journey to Neptune, Voyager 2 captured not only images of the ice giant, but also numerous images of its steady companions. Among the most unusual of all known Neptune moons is undoubtedly Proteus. In contrast to most other satellites in our solar system, this small celestial body does not have a spherical structure. In fact, in the run-up to the Voyager 2 mission, mankind knew nothing of the existence of this unorthodox satellite, even though Proteus is the second largest known moon of Neptune after Triton. Triton. As the unmanned spacecraft flew past the ice giant and its moons on August 25, 1989, finally, the first detailed images of the largest known Neptune satellite were taken. As we can clearly see in these images, the surface of the celestial body is adorned by countless faults. At the same time, the outer surface of the moon has only a few meteorite craters. This circumstance led the experts to the realization that the moon is still geologically active. The older impact craters on the surface of the satellite were erased from the galactic landscape by geological and atmospheric processes. No less interesting was the discovery that a pronounced cryovolcanism prevails on the celestial body. Thus, many active geysers could be seen, which spew a mixture of dust particles and liquid nitrogen into their environment. The corresponding fountains can reach heights of up to 5 miles. When the mixture subsequently falls back to the